These are the questions that I had asked you to do earlier as you practice to find the tangent plane and normal line to a surface. Now, remember, generally, you want the equation of the tangent plane. You remember that z is equal to delta z by delta x times a change in x plus delta y plus delta z, by delta y times a small change in y. Remember that formula there? Now, for this case, that small change in z, well, I shouldn't say z, small change in z equals that, right? That's the general formula, the form that a general formula takes. So this small change in z would be z minus z naught equal delta z by delta x times x minus x naught plus delta z by delta y times y minus y naught, where x naught and y naught, x naught will be 5, y naught is 3, z naught is whatever you get when you substitute 5 and 3 here into the equation. Alright? Now, here it can also be considered that if you should say delta z by delta x, x minus x naught plus delta y, delta z by delta y, y minus y naught plus delta z by delta z, z minus z naught equals 0. You see that? Now, here, if you do this, you'd have to say minus, right? You'd have to subtract this part. So this is times negative 1, because you're subtracting z minus z naught here, so it's negative 1. So if you have the equation in this form, you'd have to say minus this, or plus negative of this. Alright? Now, delta z by delta z would be what? It's 1. So, negative delta z by delta z with negative 1. Alright? Now here, when it comes to the normal line, you remember that y equals mx plus c. We're going to come back to this negative 1 thing later on. Now the m is a gradient, is a gradient function, is a derivative. So this would be delta z by delta y. Now in this case, it's dealing with y. So this is y. Alright? Oh, no. This is a parameter t. This would be a new variable you introduce, parameter t. Right? Plus y naught. You remember that? X would be equal to delta z by delta x t plus x naught, and z would be equal to delta z by delta z t plus z naught. Now, as for this part, you will always find that delta z by delta z would be would be 1, and then because of this minus is negative 1. So it's negative t that you would have. negative 1 t. So the parametric equation for the thing there, the normal line in that case would be z equal negative t plus z naught. Alright? Remember the basic equation, just a reminder here, the basic equation is delta z by delta z. Now sometimes f is used instead of z. So if you use f to represent the function, delta f by delta x, delta f by delta y, delta f by delta z is what you would have. Alright? Now here, we're going to look at solving the particular equations that we are given. But this is just a quick introduction to what you're supposed to do. You just look at the similarity between this equation and this. Now, here, remember, when you have it in this form, this is always going to be the form of the parametric equation for z. Right? Because you had it as z equals something happened to y and something to x and y. But then, if you want all of them together like this, you'd have to subtract. You'd have to have a negative sign. Right? So, in order to bring everything on one side and equal 0, you'd have to say, and treat them the same way, you'd have to say negative t equal negative 1t for the or negative 1t plus z naught for the parametric equation for z. Now let's quickly look at this first equation here. 7f. Now we have f of x, y, z equals 7x squared minus 8xy plus 16y cubed. And remember that I'm not in the best of health right now, and my voice isn't so well at the moment, but I'll try to make you able to hear me. So z equals 7x squared. Z equals 7x squared. That's question 1. Z equals 7x squared minus 8xy plus 16y cubed. Just draw a line here. And the point is 5 negative 3. Now, z minus z naught. First, what is x naught, y naught, z naught? Well, x naught is 5, y naught is negative 3, z naught would be 7 times 5 squared minus 8 times 5 times negative 3 plus 16 times negative 3 cubed. So y naught is not. So z naught is equal to, I'm just doing it on my calculator here, 5525 times 7, 175 plus 8 by 5 by 3. It's going to be a plus 120. It's going to be a minus now. So this is 3 3s 9 9 3s 27 times 16, 432. So 432 is a negative 432 plus 120 plus 175 gives me negative 137. So that's negative 137 there. Alright, so you see that. Now, delta Z by delta x. Let me just write the whole equation. Z minus Z naught equals delta Z by delta x, x minus x naught, delta Z by delta x, x minus x naught, plus delta Z by delta y, y minus y naught. Now delta Z by delta x. In this case, Z minus Z naught, so Z naught again, negative 137, so it plus 137 equals delta Z by delta x would be 2714x minus 8y x minus x naught plus delta Z by delta y is what? Negative 8x plus 16 times 3, that's 48, y squared times y minus y naught. But remember, x naught was what? 5. So I could just put 5 here. Oh, alright, let's leave it alone and then do that in the next line. So Z plus 137 equals. Alright, now what happened at x naught and y naught? What we have is 14 times x naught, which is 5, minus 8 times y naught, which is negative 3, x minus 5 plus negative 8 times 5 plus 48 times negative 3 squared. Alright, times negative 3 squared, y minus y naught, which is negative 3, so y plus 3 then. Alright, so 14 times 5 is 70, plus 8 3 is 24, this is 94, x minus 5, right? That's 94. X minus 5 plus, and then we work out negative 8540 is going to be a plus, you know. 3 3 is 9. 9 by 48. 432. Y plus 3. Now, Z is equal to, alright, we can subtract the 137 after. This is 94x minus 94 by 5. It was 470. 432 minus 40 is 392. 392 y plus 3 minus 137. So z is equal to 94x. Let's put these two numbers together. So far 470 and 137, 607 minus 607 plus 392y plus 392 times 3 is 1176. Alright, so z is equal to 94x plus, then we have 392y and 1176 minus 607 is equal to 569. Alright, so that's the tangent plane equation. I'm going to work out the normal line equation in a different video.